So the question is, find the pivot integer. In this question, we have given an integer n and we have to return a pivot integer x such that the sum of 1 to x both inclusive and the sum of x to n both inclusive is equal. And if any pivot integer that uh, follow this property is not present, then we will return -1. So the approach is of two pointers. Like thinking of we want to create a we want to make sum from 1 to n. So we will be taking s at 1 and e starting index at 1 and e at starting position at 1 and end position at n. And we will maintain two sum, the front sum and the end sum. So the front sum initially is equal to s and the end sum initially is equal to e. And now we will iterate in a loop. We will traverse in a loop. The loop will traverse while s less than e. What we will do? If the start sum is less than the end sum, then we will increment the s by 1 and then add the front sum. Increment front sum by s. Else, in the else condition there are two clauses. Whether the end sum is greater than front sum or both are equal. So in that case we will decrement e by 1 and we will increment the end sum by e. So after the loop is traversed completely, we will check if the front sum is equal to end sum. Then we will return s. So why s? Because in the else condition we are decrementing e. So in the last position, when the sum becomes equal, s less than e, and e like at the end, we will decrement the e. So e will decrement. So we will return s because s is the position. And when s and e both are at the same place, e will get decrement. So we will return s. Else we will return -1. So this is the question. We are using the two pointers approach. So the sign complexity is O(n) and space complexity is O(1).